Chapter 1. The Throne of the Known King. For decades, we believed we'd found the absolute ceiling of the cosmos. We convinced ourselves that we had mapped the boundaries of the impossible and looked into the eyes of the ultimate predator. To understand where we are going, you first have to remember where we've been. You have to look at the king that has sat on the throne of our nightmares since 1957. Imagine a single grain of sand on a beach that stretches for an eternity. That grain is Earth. Every person you have ever met, every war that has shaped our history, every empire that has risen and fallen, and every silent prayer ever whispered, it all exists on that microscopic speck. As we pull away, watch as our blue marble shrinks into the absolute black. We are accelerating now, pushing past the moon, past the gas giants, and leaving the warmth of our sun behind. To us, the sun is a god. It holds 99% of the mass in our solar system, but in the region of space we are entering, the sun is nothing more than a flickering candle in a hurricane. We are crossing the interstellar ocean, the vast silent void between the islands of stars. Already the scale is beginning to break. We pass Sagittarius A star, the heart of our own Milky Way. It is a monster 4 million times more massive than our sun, a gravitational anchor that holds hundreds of billions of stars in a majestic spiral. For a long time, we thought this was the peak of power. We were wrong. Sagittarius A star is a mere toy compared to the Titan we once thought was the end of the line. We travel 10 billion years into the past, to a time when the universe was a violent, crowded nursery. And there, near the border of the constellations Cans Venatici and Coma Berenices, we find it. TON 618. When astronomers first spotted this faint blue glow, they thought it was just another star in our own galaxy. But as the data trickled in, the reality shattered their models. This wasn't a star. It was a beacon screaming at us from the edge of the observable universe. TON 618 is a quasar, an active galactic nucleus so brilliant that it outshines 100 trillion suns combined. If you placed it at the center of the Milky Way, it would be 23 times brighter than a full moon, completely erasing our night sky and drowning out every other star in our galaxy. But the light is just the mask. Behind that fire lies a shadow 66 billion times heavier than the sun. To visualize TON 618 is to watch the laws of physics bend until they snap. Its event horizon, the point of no return, is a sphere of darkness 400 billion kilometers across. Our entire solar system, from the sun to the furthest reaches of the Kuiper Belt, could be dropped into this void and vanish with room to spare. This is the known king. For years, TON 618 has been the benchmark for the ultramassive. It was the object that forced us to rewrite our textbooks. We looked at its 66 billion solar masses and we asked, how is this even possible? Physics suggests there should be a limit, a theoretical ceiling of around 50 billion solar masses. Beyond that, the math says a black hole should struggle to maintain its accretion disk. It should become too large to feed efficiently. And yet, TON 618 exists. It sits there, 10 billion light-years away, as a photonic relay from a younger, more chaotic universe. We see it not as it is now, but as it was when the cosmos was just a fraction of its current age. It tells a story of a direct collapse, the idea that this monster didn't grow slowly from a dying star, but was born from the sudden, violent collapse of a primordial gas cloud the size of a galaxy. But even as we marveled at this giant, a disturbing realization began to take hold in the scientific community. The deeper we looked into the data, the more we realized that TON 618 was an anomaly that shouldn't be alone. We noticed that the gases orbiting this beast were moving at a terrifying 7,000 kilometers every single second. This broadline region told us that the gravitational influence here was so immense, it was literally shredding the fabric of the local neighborhood. But why does TON 618 stand so far apart? Why is it such a lonely titan? For a decade, we were content with this being the ultimate destination. We made videos about it, we wrote papers about it, and we used it as the final boss in every scale comparison ever made. We thought we'd reached the edge of the map, but there was a signal coming from a different direction. A signal that didn't come from a lonely quasar, but from the heart of a massive architectural structure called the Phoenix Cluster. While we were staring at the known king, something far larger and far more mysterious was hiding in plain sight, anchored by a force that doesn't just swallow matter, but shapes the very architecture of the universe itself. You see, the problem with TON 618 is that it is a relic. It is a snapshot of the past. But what happens when a black hole of that magnitude has another 10 billion years to feed? What happens when the ceiling of 50 billion solar masses isn't just broken, but completely demolished? We're about to leave the known king behind. We're about to travel to a place where the light doesn't just shine, it orbits in perfect, permanent circles in a gravitational cathedral. We're heading to a region where the black hole isn't just a resident of a galaxy, but the master of 1,000 galaxies. Prepare yourself. We're moving beyond the 66 billion suns of TON 618. We are moving toward a shadow that weighs 100 billion suns, a shadow that shouldn't exist according to every model we have. We are beginning our journey to Phoenix A, and as we leave the light of the unknown king, remember this: in the dark corners of the early universe, where we haven't yet mapped, the monsters we've found are likely only the children of the titans that truly rule the void. The throne is about to be reclaimed. Chapter 2: The Signal from the Phoenix. To find the next king, we have to look away from the lonely beacons and toward the most crowded, violent neighborhoods in the cosmos. For years, astronomers were mesmerized by the isolated brilliance of TON 618, but a different kind of signal was beginning to emerge from a region of space known as the Phoenix Cluster. This wasn't the clear, sharp scream of a distant quasar. It was something more complex, a photonic relay, buried within a chaotic web of 1,000 galaxies, 5.7 billion light-years away. When we first turned our telescopes toward the Phoenix Cluster, we didn't expect to find a record breaker. We were looking at a graveyard that was somehow acting like a nursery. In any other massive galaxy cluster, the central black hole acts as a cosmic thermostat. It fires out relativistic jets that blast through the surrounding gas, heating it up and blowing it away, effectively killing the galaxy by preventing new stars from ever forming. This is the standard feedback model we've used for decades to explain why the largest galaxies in the universe eventually stop growing. But as the data from the Phoenix Cluster began to stream in, that model didn't just bend, it shattered. Astronomers noticed a signal that defied every law of galactic evolution. In the heart of this cluster, stars weren't dying out. They were being born at a ferocious, impossible rate, nearly 800 new stars every single year. For comparison, our own Milky Way produces maybe 1 or 2. This was a failure of models on a cosmic scale. How could a region dominated by such extreme gravity and energy output allow for such a peaceful, creative process? This was the first hint that the object at the center of the Phoenix Cluster wasn't just another version of TON 618. It was something entirely new. As we followed the data deeper into the heart of the cluster, the mystery only grew darker. We began to measure the motion of the gas clouds swirling around the central galaxy, looking for the source of this feedback failure. What we found was a gravitational shadow so immense that it began to redefine our understanding of ultramassive. We weren't just looking at a 66 billion solar mass entity. The calculations were returning numbers that felt like errors in the code: 80 billion, 90 billion. And finally, the figure that stopped the conversation: 100 billion solar masses. This is the signal from the Phoenix. It is a discovery that challenges the very architecture of the universe. To understand the scale of Phoenix A, you have to realize that it is 50% larger than TON 618. If you took every star in the Milky Way, all 400 billion of them, and condensed their mass, you would only have 4 objects the size of Phoenix A. It is a mass so concentrated, so overwhelmingly heavy, that it creates a localized distortion in the expansion of the universe itself. But it's not just the size that haunts the scientific community, it's the nature of the signal itself. Most supermassive black holes reveal themselves through the violent shredding of matter in their accretion disks, shining as quasars that drown out their host galaxies. But Phoenix A is different. It is overfed. The signal we receive tells a story of a black hole that has reached such a staggering scale that it may have transitioned into a hypermassive gravitational sink. At this weight, the standard physics of an accretion disk, the friction, the heat, the predictable flow of matter, begins to break down. There is a theory, debated in the most obscure corners of astrophysics, that Phoenix A has entered a phase where its event horizon is so large that it no longer shreds matter in the way we expect. Instead, it might be swallowing entire gas clouds and star systems whole, without the typical scream of radiation we see from smaller titans. This could explain the paradox of the Phoenix cluster. The black hole is so large and its gravitational pull so absolute that its feedback mechanisms are misaligned or intermittent, allowing the surrounding gas to cool and collapse into stars even as the monster at the center continues to grow. This photonic relay is a message from a future we didn't think was possible yet. We used to believe that black holes had a natural ceiling, a point where they would become so energetic that they would inevitably push away their own food supply and stop growing. We thought 50 billion solar masses was the limit. TON 618 was already an anomaly that pushed that limit to the edge. But Phoenix A has completely demolished that ceiling. It suggests that in the dense, dark hearts of galaxy clusters, black holes can continue to merge and feed until they become anchors for the cosmic web itself. As we approach the boundary of the Phoenix cluster, the sheer density of the environment becomes suffocating. We are moving through a region shaped by a single overwhelming source of power. This isn't just an isolated monster in a void. This is a king that has built a cathedral of galaxies around itself. The light we see from the cluster isn't just coming from the stars, it's being bent, stretched, and refocused by the mass of an object that defies measurement. The discovery of Phoenix A forces us into a state of scientific humility. It reminds us that our maps of the universe are still unfinished, and our models of how galaxies live and die are based on a very small sample size of the cosmos. We thought TON 618 was the final destination, the ultimate scale of what gravity could achieve. But the signal from the Phoenix tells us that we're only looking at the foothills of a much larger mountain. We're no longer just observing a black hole. We're observing a transitional object, a bridge between the world of galaxies we understand and a dark, hypermassive reality we're only just beginning to glimpse. The Phoenix is calling, and as we move closer, we have to leave behind everything we thought we knew about the limits of the possible. We're entering the realm of the 100 billion. We're entering the shadow of Phoenix A. Chapter 3: Shattering the 100 billion barrier. To understand the magnitude of the barrier we're about to shatter, we must first accept that our human brains were never designed to comprehend the numbers we're about to discuss. We evolved to understand the distance between watering holes and the weight of a stone. We are now attempting to weigh the ghost of 100 billion suns. We begin our final acceleration, leaving the 66 billion solar mass shadow of TON 618 behind. In the distance, the known king shrinks, its 400 billion kilometer event horizon becoming just another pinprick of darkness in the rearview mirror of our journey. We are crossing a scale gap that shouldn't exist. If TON 618 was a city, a sprawling complex metropolis of gravity, then Phoenix A is a continent. As we approach the heart of the Phoenix cluster, the universe seems to rearrange itself around us. The landmarks we use to navigate the cosmos, the constellations, the familiar spirals of galaxies, begin to lose their meaning. We are entering a region where distance is no longer measured in space, but in the sheer weight of existence. We are approaching the 100 billion solar mass threshold. Think back to the grain of sand. We told you that Earth was a single grain on an infinite beach. We told you the Sun was a giant, holding nearly all the mass of our solar system. But to visualize the jump from TON 618 to Phoenix A, we have to change the game. Imagine TON 618 as a massive leaden sphere the size of a mountain. It is already an impossibility, an anomaly that breaks the 50 billion solar mass ceiling that theorists once believed was the absolute limit for black hole growth. But as we pull up alongside Phoenix A, that mountain is swallowed by a shadow that stretches from horizon to horizon. This is the 100 billion barrier. It is a number so vast that if you were to count every star in our Milky Way galaxy, 400 billion points of light, it would take only 4 objects like Phoenix A to equal the mass of our entire galaxy's stellar population. We are no longer looking at a single celestial object. We are looking at a gravitational sink that has concentrated the mass of an entire galactic history into a single point of infinite density. Current estimates suggest this monster is 100 billion solar masses, and some astronomers, looking at the way it anchors the surrounding cluster, believe it could be even larger. This is where measurement begins to defy the measurer. At this scale, the indirect methods we use, analysing the motion of surrounding gas or the luminosity of the core, begin to feel like trying to measure the depth of the ocean with a ruler. But why is 100 billion a barrier? Why does this specific number haunt the halls of astrophysics? Because according to our best models, a black hole this large shouldn't be able to stay active. We call it the feedback paradox. Normally, as a black hole feeds, it releases so much energy that it clears its own neighbourhood, pushing away the very gas and dust it needs to grow. It's a self-regulating system, a cosmic thermostat. But Phoenix A has ignored the thermostat. It has bypassed the limits of standard feeding and entered a realm of growth that we can only describe as hierarchical, merging on an unprecedented scale. It is possible that Phoenix A didn't just grow by eating gas. It is a conqueror. It is the merged remnant of multiple supermassive black holes that collided eons ago in the dense, crowded centre of the Phoenix cluster. Each collision would have sent gravitational waves rippling through the fabric of space-time, echoes of a celestial war that built this titan piece by piece, breaking every law of growth we thought we understood. As we cross the threshold into the inner sanctum of the Phoenix, the light begins to behave unnaturally. This is what we call the gravitational cathedral. Because the mass is so extreme, 100 billion suns, the gravity doesn't just pull light in, it forces light into perfect permanent orbits. If you were to stand at the right distance, you could theoretically see the back of your own head as the light reflecting off you travels in a complete circle around the black hole and returns to your eyes. You're standing in a hall of mirrors made of warped space-time. But there is a darker theory hidden in the data, one that most documentaries are afraid to touch. Some theorists suggest that once you shatter the 100 billion barrier, you're no longer looking at a classical black hole. They propose that Phoenix A has transitioned into something called a hypermassive gravitational sink. In a standard black hole like Sagittarius A star or even TON 618, we have a relatively clear understanding of the accretion disk, the swirling fire of matter being shredded before the final plunge. But at 100 billion solar masses, the physics of that disk begins to break down. The event horizon is so large, and the gravitational gradient is so shallow at the edge, that Phoenix A might not even shred incoming matter anymore. It might simply swallow entire star systems whole, their light snuffed out before they ever have the chance to scream in the form of radiation. It is a silent, efficient eater of worlds. This is the transitional object theory. It suggests that Phoenix A is a bridge to a different kind of reality. At these scales, space-time around the event horizon may exhibit macroscopic instabilities. We're talking about localized distortions so severe that they might resemble separate universes branching off from our own, miniature Big Bangs occurring within the shadow of the giant. We look at the 100 billion barrier and we see a limit, but the universe sees a beginning. Phoenix A is a reminder that our theoretical ceilings are often just the limits of our own imagination. We thought 50 billion was the end. Then we found TON 618 at 66 billion. Now, we stand before the 100 billion suns of the Phoenix. The scale has been shattered, the map has been redrawn. We are now standing at the edge of Einstein's nightmare, looking into a void that doesn't just represent the death of stars, but the birth of a new kind of cosmic architecture. We have travelled billions of light years to reach this point, and yet, as we stare into the 100 billion sun shadow, we realise that the most terrifying part isn't what we can see. It's the realisation that this monster is operating under a set of rules we're only just beginning to translate. We have arrived at the summit of the known universe, but as the photonic relay of the Phoenix cluster surrounds us, we have to ask, if 100 billion isn't the limit, then what is? And more importantly, why is this giant, which should be the ultimate destroyer, allowing life to flourish in the stars surrounding it? To answer that, we have to go deeper into the paradox of the Phoenix itself. Chapter 4. The Paradox of Life in the Heart of Death. We have reached the point in our journey where the laws of cosmic evolution begin to unravel. In the standard story of the universe, a supermassive black hole is a silent executioner. It is the ultimate quencher of life. We've seen this play out with every other titan we've mapped, including the mighty TON 618. As these monsters feed, they grow so energetic that they begin to act as a cosmic thermostat. They fire out relativistic jets, plumes of plasma travelling at nearly the speed of light, that blast through the surrounding galaxy like a flamethrower. This process, known as feedback, heats up the interstellar gas and blows it into the intergalactic void. Without cool gas, stars cannot form. the galaxy is effectively strangled, turned into a red and dead graveyard where no new suns will ever rise. This is what we expected to find at the heart of the Phoenix cluster. After all, if a black hole with 66 billion solar masses can shut down a galaxy, then a monster with 100 billion suns should be the most efficient killer in the history of the cosmos. It should be a desert of absolute stillness. But as we peer into the center of this cluster, we find ourselves staring at a paradox that shatters our most fundamental models. We are witnessing the star birth paradox. Instead of a cold, dead graveyard, the Phoenix cluster is hosting a cosmic renaissance. At the very edge of the most massive gravitational shadow ever discovered, the universe is producing stars at a rate that is frankly impossible. While our Milky Way lazily produces 1 or 2 stars a year, the heart of the Phoenix is screaming out nearly 800 new suns every single year. It is a starburst of such intensity that it shouldn't be able to exist in the presence of such a hungry giant. This is the ultimate failure of models. The thermostat isn't just broken, it seems to be working in reverse. How does life, at least the stellar life required for planets and civilizations, flourish in the backyard of the ultimate death? The data tells us that something has gone fundamentally wrong with the way Phoenix A interacts with its environment. In any other cluster, the central black hole's energy output would keep the surrounding gas too hot to collapse. But here, the gas is cooling. It is raining down toward the center of the galaxy in massive frigid filaments, condensing into new stars before the black hole can consume it or blast it away. One theory, whispered in the most advanced circles of astrophysics, is the misaligned jet hypothesis. It suggests that Phoenix A's relativistic jets, those great cosmic blowtorches, are not pointing where they should be. They are misaligned, firing into the empty voids of the cluster rather than into the gas clouds that fuel star formation. Like a lighthouse with a broken lens, the energy is being beamed into the dark, leaving the surrounding galaxy in a shadow where the gas can remain cool, stable, and creative. But there is a darker, more obscure possibility provided by the scale of Phoenix A itself. Some theorists believe we're witnessing a phase where the black hole has become overfed. Imagine a predator that has gorged itself on so much matter, so many merged galaxies and captured star systems, that it has entered a state of temporary gravitational exhaustion. At 100 billion solar masses, the black hole might be so large that its feedback mechanisms are operating on a delay we've never seen before. It is so massive that it is effectively ignoring the star formation in its outer rim, unable to regulate its surroundings because it has transitioned into a hypermassive sink. In this state, the black hole is no longer a localized predator. It is an environmental condition. It is so heavy that it is pulling in gas from such vast distances that its own jets can't keep up with the sheer volume of material. The monster is essentially drowning in its own food supply. This creates a terrifying irony. The most powerful destroyer in the universe is inadvertently acting as a protector, allowing for a burst of creation that the rest of the cosmos hasn't seen since the Big Bang. We call this the paradox of life in the heart of death. It forces us to reconsider the role of these giants. We've always viewed black holes as the end of the story, the final stage of matter, but Phoenix A suggests they might be part of a much more complex cycle. If the largest black hole in the universe is allowing, or even encouraging, the birth of 800 suns a year, then the relationship between gravity and life is not as antagonistic as we once thought. As we drift through these nursery clouds of glowing gas, shadowed by a void the size of a solar system, we have to ask ourselves, is this an accident? Or is this a necessary stage in the life of a hypermassive object? Some fringe theories suggest that the extreme star formation we see is actually a pre-feeding event, that the black hole is effectively farming these stars, allowing them to form so that it can eventually consume them as a concentrated source of mass eons from now. It is a humbling realization. Every model we have built to explain the evolution of galaxies assumes that monsters like this are the enemies of stars. Yet, here we are, 5.7 billion light-years from home, looking at a cathedral of light built in the shadow of the ultimate darkness. But this creative peace cannot last forever. The gas that is currently forming stars is also being pulled inch by inch toward that 100 billion sun event horizon. The gravitational cathedral we discussed isn't just a place where light orbits, it is where the very building blocks of the universe go to be forgotten. And as we look closer at the boundary where the starbirth ends and the darkness begins, we see hints of something even more disturbing. we see evidence that Phoenix A isn't just one object, but a collection of shadows that have finally become one. To understand how a black hole reaches this overfed state, we have to look back at the history of the cluster itself. We have to look at the hierarchical mergers that created this titan. Because the story of Phoenix A isn't just a story of growth, it's a story of conquest. And the life we see blooming here today might just be the last flickering candle before the final, total eclipse. We are standing at the edge of the most productive and most destructive region in the known universe. It is a place where the rules of physics are being rewritten in real time. And as we prepare to move closer to the very lip of the abyss, we must leave behind our definitions of life and death. In the Phoenix cluster, they are two sides of the same gravitational coin. Chapter 5: Einstein's Nightmare, the Gravitational Cathedral. We are now leaving the turbulent, glowing nurseries of the Phoenix cluster's outer rim, moving away from the frantic birth of 1,000 suns and toward the silent, absolute center of the storm. Behind us, the 800 stars being born every year fade into a chaotic mist of gold and blue. Ahead lies a region where the very concept of space begins to dissolve. We are entering the domain of Einstein's nightmare, the most extreme gravitational environment ever conceived by the human mind. To understand where we are, we must first confront the scale of the void that is rushing up to meet us. We have already established that TON 618 was a titan, a shadow 400 billion kilometers across. But as we approach Phoenix A, that scale is shattered once again. We are looking at an event horizon, the boundary beyond which nothing, not even light, can ever return, that is likely 50% larger or more than the previous champion. This is a sphere of absolute darkness so vast that if you were to place it at the center of our solar system, it would not just swallow the planets, it would consume the Kuiper Belt, the Oort cloud, and the vast interstellar distances beyond them before a traveler would even reach its lip. This is no longer just a black hole. According to the most advanced and obscure theories emerging from the data, we are approaching what some theorists call a transitional object. This is a state of existence that sits between the black holes we understand and a total breakdown of the cosmic order, a hypothetical, hypermassive gravitational sink. At the mass of 100 billion suns, the laws of physics that govern the rest of the universe are not just bent, they are rendered unrecognizable. As we move closer, the first thing you notice is the light. You're entering the gravitational cathedral. In a standard black hole, light is either pulled in or deflected away. But here, the gravitational influence is so profound and so overwhelming that it forces light into a permanent, perfect orbit. You're now standing in the photon sphere. If you were to stop your ship here and look straight ahead, you would see the back of your own head. The light reflecting off you travels in a complete circle around the 100 billion sun mass and returns to your eyes. You're suspended in a hall of mirrors created by warped space-time, seeing the entire history of the cluster's light trapped in a celestial loop. But the cathedral is not just a place of visual wonder, it is a place of existential terror. This is where Einstein's nightmare truly begins. According to general relativity, gravity is the curvature of space-time. In the presence of Phoenix A, that curvature is so extreme that space-time begins to exhibit macroscopic instabilities. The math suggests that at this scale, the fabric of our reality may be tearing. Some theorists speculate that these instabilities create localized distortions, bubbles of altered physics that resemble separate universes branching off from our own. You're no longer just in a galaxy. You're at a crossroads where our universe may be leaking into another. Look at the horizon itself. It is not a flat surface of blackness. Because of the sheer mass, the gravitational gradient at the edge of Phoenix A is surprisingly shallow compared to smaller black holes. In a stellar mass black hole, the difference in gravity between your head and your feet would shred you instantly in a process called spaghettification. But here, at 100 billion solar masses, you could theoretically cross the event horizon without feeling a thing. You would simply slip from the world of the living into the world of the lost, unaware that you have left the observable universe forever. This is the ultimate failure of models. We used to believe there was a limit to how large these structures could grow before they destroyed their surroundings. Scientists proposed a theoretical size limit of roughly 50 billion solar masses, suggesting anything larger would be unable to maintain its accretion disk. But Phoenix A stands as a silent refutation of our arrogance. It is a photonic relay from a realm of physics we are only just beginning to translate. As we hover at the edge of the abyss, time itself begins to lose its meaning. We know that gravity slows time, but here, the effect is total. Near the event horizon of Phoenix A, seconds do not just stretch, they become centuries in the world we left behind. If you were to look back at the Phoenix cluster from this vantage point, you would see the universe in fast forward. You would see stars age and die in the blink of an eye. You would see the entire cluster evolve, shift, and eventually fade into darkness while you remain frozen at the edge of eternity. You're effectively separated from the timeline of the universe. To an outside observer, you would appear as a crimson ghost, frozen in place as your light is gravitationally redshifted into the longest, darkest wavelengths. The black hole is quite literally bleeding the colour and the time out of your existence. But why does this sink exist? Why does the universe allow for a 100 billion sun concentration of mass? The data suggests that objects like Phoenix A may act as anchors for the cosmic web. We are not just looking at a consumer of matter, we are looking at a pillar. There is a theory that these hypermassive objects are what hold the large-scale filaments of dark matter together, shaping the architecture of the entire universe. Without the terrifying gravity of the Phoenix, the galaxies in this cluster might drift apart, and the cosmic web itself might begin to unravel. This challenges the idea of the black hole as a mere destroyer. It suggests that at the highest scales, these objects are the fundamental architects of everything we see. The mystery deepens when we consider the feedback failure we witnessed in the previous chapters. Standard models tell us that a black hole this massive should be screaming with energy, launching relativistic jets that halt all star formation. But Phoenix A is different. Some argue it is overfed, meaning it has consumed so much matter that it is temporarily unable to regulate its environment. Others suggest that conventional accretion disk physics, the friction and heat that generate a quasar's light, simply breaks down at this scale. Instead of a violent bright engine like TON 618, Phoenix A might be transitioning into a quiet, efficient sink that swallows matter without the typical radioactive protest. It is a silent god, growing in the dark, influence expanding until it reaches a scale that challenges the expansion of the universe itself. As we prepare to cross the final threshold into the singularity, we must confront the most haunting possibility of all. To build a structure this large requires more than just gas and dust. It requires a history of violence. Phoenix A is likely not a single object, but the merged remnant of multiple supermassive black holes that collided eons ago in the dense heart of the cluster. Each collision would have sent gravitational waves rippling through space-time, echoes of a celestial war that built this titan piece by piece. We are standing on the ruins of dozens of galaxies, all crushed into a single point of infinite density. We are standing on the precipice of the unknown. Behind us is a universe of light, starbirth, and time. Ahead of us is a singularity where density becomes infinite, and where every equation we have ever written ends in a zero. This is the heart of the gravitational cathedral. It is a place of perfect symmetry and absolute destruction. It is the end of the journey for the matter that falls in, but for us, it is the beginning of a deeper mystery. We have shattered the 100 billion barrier, we have witnessed the paradox of life, and now we're staring into the eyes of Einstein's nightmare. The question is no longer how big Phoenix A is. The question is, what is it doing to the rest of the universe? As the light of the cluster fades into a deep gravitational crimson, we realize that we're not just observers. We are witnesses to the final stage of cosmic evolution. The throne is no longer empty. The King of Shadows has been found. And as we descend into the final darkness of the cathedral, we must ask ourselves, if this is what we can see from the edge of the abyss, what is waiting for us in the regions where even the data cannot follow? We have reached the limit of our sight. Now, we must follow the gravity. We are moving beyond the horizon. We are moving into the singularity of the Phoenix. This journey has taken us from the microscopic grain of sand that is our home to the continental scales of a 100 billion sun void. We have seen how Sagittarius A star with its 4 million suns was just a prelude. We have seen how TON 618, the 66 billion solar mass giant, was merely a signpost. And now, in the shadow of Phoenix A, we find a reality that defies every calculation. If the universe is only 13.8 billion years old, how does such a monster have the time to exist? The direct collapse of gas clouds might explain the young titans of the early universe. But But Phoenix A suggests something even more extreme, a process of hierarchical merging that hasn't stopped since the first stars ignited. The light we see from Phoenix A today is a message from 5.7 billion years ago. In the time that light has spent travelling to our telescopes, how much larger has this monster grown? If it was already 100 billion suns, then what is it now? Is there a point where a black hole stops being a black hole and becomes the universe itself? As we lose our sense of up and down, as landmarks disappear and only distance remains, we realise that the gravitational cathedral is not just a place, it is the future. It is the ultimate fate of all matter that cannot escape the pull of the dark. We linger here, at the boundary, one last time. We watch the light of 1,000 galaxies orbit the abyss in a perfect glowing ring. This is the most beautiful and terrifying thing the universe has to offer. It is a monument to the power of gravity and a tomb for everything that ever was. We have crossed the boundaries of scale, and as we look into the absolute black, we finally understand. The universe is not just bigger than we thought. It is more dangerous, more creative, and more mysterious than we could have ever imagined. The journey to the centre of the Phoenix is a journey to the heart of the mystery itself, and as we finally cross the threshold, the silence is absolute. The darkness is complete. We are home. Chapter 6. The Hierarchical Merger Theory. To stand before the shadow of Phoenix C is to confront a mathematical impossibility. As we hover at the edge of the gravitational cathedral, we are forced to ask the question that has ignited a firestorm of debate in the halls of modern astrophysics. How does an object like this even exist? It's a question that strikes at the very heart of our understanding of time, gravity, and the history of the cosmos. For decades, we believed that black holes followed a predictable, albeit terrifying, path of growth. We thought we had mapped the limits of their hunger, but Phoenix A has proven that we were looking at the universe through a keyhole. To understand the mystery of the Phoenix, we first have to look at the standard way a giant is born. For a long time, TON 618 was our benchmark. At 66 billion solar masses, it pushed the boundaries of the direct collapse theory. The idea was simple. In the early chaotic universe, massive clouds of primordial gas, vast enough to swallow 1,000 galaxies, collapsed under their own weight. They didn't bother with the slow process of forming stars and waiting for them to die. They went straight to the singularity. This process created the seeds of the ultramassive black holes we see as quasars at the edge of the observable universe. But even with a head start that massive, TON 618 is still only 66 billion suns. Phoenix A is nearly double that mass, and that's where the math breaks. If you assume that Phoenix A grew the same way TON 618 did, by simply feeding on gas and dust over billions of years, you run into a brick wall called the Eddington limit. This is the theoretical speed limit for how fast a black hole can eat. As matter spirals into the abyss, it heats up and releases radiation. Eventually, that radiation becomes so intense that it pushes away the incoming food. It's a cosmic safety valve that prevents black holes from growing too fast. To reach 100 billion solar masses by feeding alone, Phoenix A would have had to break this limit every single day for 13 billion years. It would have had to eat at a rate that defies every law of physics we have ever written. So, if it couldn't have grown this big by eating, there is only one other conclusion. Phoenix A didn't grow, it was built. We are now entering the realm of the hierarchical merger theory. This is the active discovery angle that is currently reshaping our view of the Phoenix cluster. As we analyse the data from this region, we aren't just seeing one massive object, we are seeing the final result of a cosmic war. The Phoenix cluster is one of the densest, most crowded environments in the universe. It is a place where gravity doesn't just pull, it entangles. In this region, galaxies aren't isolated islands, they are targets. Imagine a time, billions of years ago, when the Phoenix cluster was a chaotic battlefield of young, massive galaxies. In the heart of each of those galaxies sat a supermassive black hole, monsters in their own right, perhaps 10 or 20 billion suns each. As these galaxies were pulled together by the overwhelming gravity of the cluster, they began to collide. When two galaxies merge, their central black holes don't just sit there, they sink. Through a process called dynamical friction, they lose energy and spiral toward the center of the newly formed galaxy, drawn to each other by an irresistible, invisible thread. This is the beginning of the dance of the giants. For millions of years, these two black holes would orbit each other, shredding stars and distorting the surrounding space as they move closer and closer. Eventually, they reach a point of no return, a final, violent embrace. When two objects of such staggering mass collide, they don't just merge, they shatter the fabric of space-time. The hierarchical merger theory proposes that Phoenix A is the ultimate synthesis of this process. It isn't just one black hole. It is the merged remnant of multiple supermassive black holes that have collided eons ago. We are looking at a conglomerate titan, an object formed not by the slow accretion of gas, but by the repeated violent fusion of the largest structures in the universe. This isn't just growth, it is an architectural conquest. But why do we think this happened here, in the Phoenix cluster, more than anywhere else? The answer lies in the feedback failure we discussed earlier. In most galaxy clusters, a single black hole dominates and keeps the neighborhood quiet. But in the Phoenix cluster, the environment is so dense that the standard thermostat never had a chance to settle. The cluster was constantly being fed new galaxies, new gas, and new black holes. It was a direct collapse event that never stopped. As we follow the data, we begin to see the gravitational echoes of these mergers. When two black holes collide, they release a burst of energy in the form of gravitational waves, ripples in the very fabric of the universe that travel at the speed of light. In a merger involving 10 billion sun masses, these waves would be so powerful that they would literally stretch and squeeze the space across billions of light years. While our current detectors, like LIGO, are tuned to find the collisions of small stellar mass black holes, the echoes of Phoenix A's birth are on a scale we can barely imagine. There is a theory that future space-based gravitational wave detectors will be able to pick up the low-frequency hum of these hierarchical mergers. These wouldn't be sharp chirps, they would be deep tectonic groans of space-time itself. Astronomers are actively searching for these signals, looking for proof that Phoenix A is a hierarchical masterpiece. If we find them, it would confirm that we are living in a universe where the most massive things aren't born. They are forged in the fires of galactic collision. But the hierarchical merger theory also raises a terrifying new possibility. If Phoenix A is the result of multiple mergers, then what happens to the sparks that were thrown off during those collisions? When black holes of this size merge, the energy released can sometimes kick the resulting black hole out of the center of its galaxy at millions of miles per hour. This gravitational recoil is a fringe idea that suggests there could be rogue, ultramassive black holes wandering through the intergalactic voids, monsters the size of TON 618 that were ejected from their homes during the birth of titans like Phoenix A. As we look at the 100 billion sun shadow, the active discovery process forces us to confront our own scientific humility. We used to think that the 50 billion solar mass ceiling was a hard limit. We thought the universe had a rulebook for how big a black hole could get, but Phoenix A suggests that the rulebook was only written for a certain kind of growth. The hierarchical merger theory tells us that the universe has a cheat code for creating giants. It tells us that in the right environment, with enough matter and enough time, there is no limit to how large a shadow can grow. This theory changes the way we look at the starbirth paradox as well. If Phoenix A was formed by a series of massive mergers, the chaos of those collisions would have sent shockwaves through the surrounding gas, potentially triggering the intense star formation we see today. The life in the Phoenix cluster might not be an accident. It might be the afterglow of a merger that happened billions of years ago. The black hole isn't just sitting there, it is still settling into its new hypermassive form. We are watching a titan in transition. We are seeing an object that has moved beyond the classical phase of black hole evolution and entered a state of hierarchical dominance. Phoenix A is a reminder that the universe is a work in progress. It is a photonic relay from a history of violence and creation that we're only just starting to map. As we move deeper into the data, we realize that the scale of Phoenix A is more than just a record. It is a clue. It tells us that the early universe was far more crowded and far more active than we once believed. It tells us that the seeds of these giants were planted in a time of extreme density, and that they have been merging and growing in the shadows of the cosmic web ever since. But if Phoenix A is the merged remnant of several supermassive black holes, what does that say about the future of the Milky Way? We know that our own galaxy is on a collision course with Andromeda. We know that in a few billion years, Sagittarius A star will meet the black hole at the center of Andromeda. They too will dance, they too will spiral, and eventually they too will merge. We are seeing the distant, hyper-evolved future of our own neighbourhood. We are seeing the end result of a process that begins with a single star and ends with a 100 billion sun sink. The active discovery of Phoenix A is not just about measuring a giant. It is about understanding the grand design. If hierarchical merging is the primary way these monsters grow, then the universe is a place where the largest things are constantly getting larger. There is no final size. There is only the next merger, and somewhere out there, in the regions of space we haven't yet surveyed, there could be two Phoenix A-sized titans currently locked in a gravitational embrace, preparing to shatter the 100 billion barrier and create something even more incomprehensible. We look at the Phoenix and we see a king, but the hierarchical merger theory suggests that we should see a survivor. We should see a titan that has outlasted 1,000 galaxies and consumed 12 kings to reach its throne. It is a monument to the endurance of gravity and the sheer, relentless power of collision. As we prepare to leave the active phase of our investigation and dive into the most speculative theories of all, we have to carry this realization with us. The universe does not respect our limits. It does not care about our ceilings or our models. It is a machine that builds giants out of shadows, and Phoenix A is its greatest achievement so far. The signals are there. The data is calling. And as we listen to the gravitational echoes of the Phoenix, we realize that we're no longer just looking back in time. We are looking at the mechanism of creation itself. The hierarchical merger is the heartbeat of the ultramassive universe, and in that heartbeat, we find the origin of the monster that now commands the void. But how does such a giant influence the very architecture of reality? If it was built by mergers, what does it do now that it has reached the top of the mountain? To answer that, we have to look away from the center and out toward the filaments of the cosmic web. We have to look at the theory that Phoenix A isn't just a resident of the universe. It is an anchor that holds the entire structure together. We have found the origin of the king. Now, we must understand the extent of its kingdom. We are moving from the history of the merger to the reality of the anchor. We are moving toward the final chapters of our journey, where the scale of Phoenix A begins to overlap with the scale of the universe itself. The mystery of the 100 billion suns is no longer just a question of mass, it is a question of purpose. And as we stand in the light of the photonic relay, we realize that the story of the Phoenix is only just beginning to be told. The echoes are still ringing, the mergers are still happening, and the king is still growing. Chapter 7. Beyond black holes, the hypermassive sink, we have spent our entire journey comparing giants. We have looked at the 4 million sun shadow of Sagittarius A star and the 66 billion sun majesty of TON 618. We have treated these objects as if they were all part of the same family, simply bigger and smaller versions of the same gravitational engine. But as we stand before the 100 billion sun reality of Phoenix A, we must confront a truth that many in the scientific community are only just starting to whisper. We are no longer looking at a black hole. We are looking at something that has moved beyond. To understand the nature of Phoenix A, we have to look back at the rulebook we thought the universe followed. For years, theorists proposed a firm, unbreakable ceiling for black hole growth, a limit of roughly 50 billion solar masses. The logic was sound. As a black hole grows, the radiation from its feeding process becomes so intense that it should effectively blow away its own food supply. It was thought that once a black hole hit that 50 billion sun mark, it would lose its accretion disk entirely. It would become quenched, unable to maintain the constant intake of matter required to grow any further. But Phoenix A is 100 billion solar masses. It has not just touched the ceiling, it has smashed through it and built a new floor. This brings us to the most profound mystery of our journey, the hypermassive gravitational sink. There is a theory, debated in the deepest corners of speculative astrophysics, that Phoenix A is a transitional object. It is a state of existence that sits between the classical black holes we understand and a total structural failure of the cosmic order. At this scale, the very physics that defined TON 618 begins to evaporate. In a standard black hole, the engine of its brilliance is destruction. Matter is shredded by tidal forces, a process we call spaghettification, and the resulting friction creates the blinding light of a quasar. But as a black hole exceeds the 50 billion sun limit and enters the realm of the 100 billion, the nature of its event horizon changes fundamentally. Because the event horizon is now so incomprehensibly large, the gravitational pull at the edge is no longer sharp. The tidal forces are actually weaker than those of a much smaller black hole. This leads to a terrifying shift in behaviour. Instead of shredding matter and creating a brilliant glowing disk of fire, a monster like Phoenix A may have reached the point where it simply swallows matter whole. This is the transition from a quasar to a sink. In this phase, the black hole doesn't scream as it eats. There is no violent friction, no relativistic jets blasting through the galaxy, and no blinding accretion disk. Instead, entire star systems, gas clouds, and dark matter filaments simply slip past the event horizon in silence. They are consumed before they have the chance to radiate their energy away. We are observing an object that is overfed, a hypermassive entity that has grown so large it has effectively silenced its own engine. This explains the feedback failure we witnessed earlier. If Phoenix A is no longer a classical black hole but a hypermassive sink, it wouldn't be firing out the energy required to stop star formation. It has become a silent, efficient eater of worlds, allowing the cluster around it to continue its creative cycle while it continues to grow in the dark. But the transition into a sink is about more than just a lack of light. It is about the breakdown of space-time itself. In the gravitational cathedral, we saw how light is trapped in perfect circles. But inside the framework of the hypermassive sink, the math suggests that the fabric of reality may be exhibiting macroscopic instabilities. We are used to thinking of black holes as stable, if extreme, features of the universe. But at 100 billion solar masses, the sheer concentration of weight in a single region may be too much for the local grid of the cosmos to support. Some theorists speculate that the event horizon of Phoenix A is a site of constant localized distortions, bubbles of altered physics where the laws of the universe are literally rewriting themselves. In these regions, the curvature is so intense that it might be creating leaks into other potential realities. You aren't just looking at a sink for matter, you're looking at a sink for the very definitions of our universe. This brings us to a new role for these giants, the dark matter anchor. For a long time, we viewed black holes as residents of galaxies, unfortunate accidents at the centre of a spiral. But as we look at the scale of Phoenix A, we realise that it may be the other way around. There is a growing consensus that ultramassive black holes like this are the structural anchors for the large-scale filaments of the cosmic web. They are not just eating the universe, they are holding it together. Imagine the dark matter web that stretches across the entire cosmos, the invisible scaffolding that dictates where galaxies form and where they move. At the intersections of these filaments, you find galaxy clusters like the Phoenix cluster, and at the heart of those clusters, you find the sinks. Phoenix A is so massive that its gravitational influence effectively anchors the dark matter filaments in its vicinity, shaping the architecture of the local universe and perhaps even subtly influencing the expansion rate of space in its local neighbourhood. It is no longer just an object, it is a pillar. This is the ultimate evolution of the known king. We have moved from a direct collapse star in TON 618 to a hierarchical merger conqueror, and finally to a hypermassive gravitational sink. Phoenix A represents a state of being that shouldn't exist in a universe only 13.8 billion years old. It is a photonic relay from a future we weren't supposed to see yet. But if Phoenix A has entered this phase, what does it mean for the ultimate fate of matter? If a black hole can stop shredding matter and start swallowing it in total silence, then there is no longer a thermostat to stop its growth. It will continue to sink, continue to pull on the cosmic web, and continue to merge with every other titan it encounters. We are looking at a glimpse of the end state of the universe. In the far, far future, when the stars have all burned out and the galaxies have drifted apart, the only things left will be these hypermassive sinks, lonely, silent anchors holding onto the tatters of the cosmic web. Phoenix A is just an early arrival. It is a reminder that the theoretical limits of our models were based on our own limited imagination. We thought the universe had a ceiling. We were wrong. As we pull back from the event horizon, we see the Phoenix cluster not as a chaotic battlefield, but as a masterpiece of gravitational engineering. The star birth paradox, the hierarchical mergers, and the Einstein's nightmare of the cathedral all converge here in the concept of the sink. It is the point where the destroyer becomes the architect, but we aren't done yet. To truly understand the power of this anchor, we have to look at what it's holding on to. We have to look past the light and the gas and into the invisible structure of the cluster itself. We have to look at how Phoenix A is literally pulling on the strings of the universe. We are moving beyond the sync. We are moving toward the dark. We are moving toward the realization that Phoenix A is not just the largest black hole we've ever found. It is the most important structural member of the local cosmos. The king has not just reclaimed the throne, he has built the entire palace around himself. The transition is complete. We have left the world of black holes behind. We are now in the era of the hypermassive sync, and in this new reality the only rule is gravity. The only destination is the dark, and the only certainty is that the universe is far more complex and far more terrifying than we ever dared to believe. We are staring into the future of everything, and the future is silent. The future is heavy. The future is the Phoenix. Chapter 8. The Dark Matter Anchor. Up until this point, we have treated the giants of the cosmos as lone predators, isolated monsters drifting in the dark, waiting for the universe to fall into their mouths. We have looked at TON 618 as a solitary king on a distant throne, and we have spoken of Phoenix A as a hypermassive sink that silently consumes everything it touches. But we have been so mesmerized by the mouth of the monster that we have forgotten to look at its hands. We have been staring at the destroyer, but we have failed to see the architect. To understand the true nature of Phoenix A, we have to pull back even further than we ever thought possible. We have to look past the event horizon, past the glowing nurseries of the starburst, and even past the thousands of galaxies that make up the Phoenix cluster. We have to look at the invisible architecture of the universe itself, the cosmic web. For decades, we have known that the matter we can see, the stars, the planets, the glowing gas, and even the giants like TON 618, is only a tiny fraction of what's actually out there. Around 85% of the matter in the universe is invisible. It is dark matter, a mysterious substance that doesn't emit light, but whose gravity acts as the glue for everything we know. Dark matter doesn't just drift aimlessly. It forms a vast, interconnected network of filaments, cosmic strings that stretch across the void, linking galaxies together like pearls on a necklace. And it is here, at the junction of these invisible filaments, that we find the true purpose of Phoenix A. In our own neighbourhood, the black hole Sagittarius A star is a supermassive beast. With its 4 million solar masses, it sits at the centre of the Milky Way, acting as a gravitational anchor that holds hundreds of billions of stars in a majestic spiral. It is the foundation of our home. But when you scale up to the 100 billion sun reality of Phoenix A, the role of anchor takes on a terrifyingly different meaning. Phoenix A is no longer just anchoring a galaxy, it is anchoring a region of the universe. There is a growing theory in the most speculative circles of astrophysics that ultra-massive black holes of this magnitude are the primary structural pillars of the cosmic web. Imagine the dark matter filaments as the cables of a suspension bridge. If the galaxies are the cars travelling along the cables, then Phoenix A is the massive, deep-rooted pylon that holds the entire structure in place. It is the dark matter anchor. Because its mass is so concentrated and so extreme, Phoenix A doesn't just pull on nearby stars. Its gravitational influence extends far beyond the cluster itself, effectively pinning the surrounding filaments of the cosmic web into a fixed position. It is a point of absolute gravitational certainty in an expanding universe. Without the presence of these hypermassive anchors, the large-scale architecture of the cosmos might be far more fluid, far more chaotic, and perhaps unable to support the dense clusters of galaxies we see today. But the lore goes even deeper. Some theorists argue that once a black hole reaches the scale of 100 billion suns, it begins to influence more than just the matter around it. They suggest that these anchors may actually interact with the vacuum energy of space itself. In the immediate vicinity of Phoenix A, the gravity is so overwhelming that it might subtly alter the local expansion rate of the universe. While the rest of the cosmos is flying apart at an accelerating pace, the region anchored by Phoenix A might be a gravitational eddy, a place where the expansion is slowed or even distorted by the sheer weight of the shadow at its centre. This changes the narrative from one of destruction to one of cosmic architecture. We have spent our history fearing the black hole as the end of all things, but if the anchor theory is correct, then Phoenix A is the reason the Phoenix cluster exists in the first place. The black hole didn't just grow because the cluster was there, the cluster formed because the anchor was already being built. It is a fundamental shift in the chicken and egg problem of galactic evolution. The anchor is the foundation upon which the star-birth paradox is built. Think about the scale of this responsibility. A single object, roughly the size of our solar system, is holding the strings for a region of space millions of light-years across. It is a photonic relay for the invisible scaffolding of the universe. When we look at the light of the Phoenix cluster, we are only seeing the decoration on the building. The actual structure, the weight-bearing members of the cosmos, is hidden in the dark, anchored by a 100 billion sun titan that we are only just beginning to understand. This perspective forces us to look at the hierarchical merger theory in a new light. If Phoenix A was built through the collision of dozens of supermassive black holes, then we aren't just looking at a merge of mass, we are looking at the fusion of anchors. Every time two giants collide, two separate pylons of the cosmic web are brought together, reinforcing the structure and creating an even stronger point of stability. The universe is literally building itself a more permanent skeleton, one merger at a time. But as with all things at this scale, there is a haunting trade-off. By acting as an anchor, Phoenix A is also ensuring its own ultimate dominance. By pinning the dark matter filaments in place, it ensures that more gas, more stars, and more galaxies will inevitably be funneled toward its center over the coming trillions of years. It is a masterpiece of self-sustaining growth. The anchor holds the web, and the web feeds the anchor. We find ourselves standing in a cathedral not of light, but of structure. We are witnessing the grand design in real time. We have moved from the known king TON 618, which we saw as a lonely anomaly, to Phoenix A, which we now recognize as a necessary component of the universe's stability. It is a sobering thought. The largest black hole we have ever discovered is not an accident. It is a pillar. But if Phoenix A is an anchor for the cosmic web, what happens if that anchor is pushed too far? What happens when the weight of 100 billion suns begins to interact with the very fabric of the vacuum? Some speculate that at this mass, we aren't just looking at an anchor for matter, but a sink for the laws of physics themselves. We are approaching the edge of the known map, where the architecture of the universe begins to overlap with the most speculative fringe ideas about the nature of our reality. As we look out across the vast, dark filaments that stretch away from the Phoenix cluster, we realize that we are part of a much larger, much older story. We are residents of a web that is tied to the shadows of giants, and as the light of the Phoenix continues to call to us across 5.7 billion light-years, it reminds us that the universe isn't just a place where things happen. It is a place that is being built piece by piece by the most terrifying and majestic structures we have ever found. The king has reclaimed the throne, the sink has swallowed the light, and the anchor has pinned the universe in place. But the journey isn't over. To truly understand what this means for the fate of everything, we have to look past the structure and into the most existential question of all. If Phoenix A is a bridge to a different kind of reality, what lies on the other side? We are moving toward the end of the line. We are moving toward the multiverse leak. Chapter 9. The multiverse leak. We have arrived at the final threshold, the place where the language of mathematics turns into the language of ghosts. We have spent our journey escalating from the microscopic speck of Earth to the continental shadow of Phoenix A, a titan estimated at 100 billion solar masses. But as we hover here, at the absolute edge of the gravitational cathedral, we must confront a possibility that is whispered only in the most speculative and obscure corners of astrophysics. We are no longer just looking at a black hole that breaks the rules of scale. We are looking at an object that might be leaking the very fabric of our reality. For decades, we treated the singularity, the point of infinite density at the heart of a black hole, as a mathematical curiosity, a place where our current understanding of physics simply breaks down. In a standard monster like TON 618, with its 66 billion solar masses, that breakdown is contained within an event horizon 400 billion kilometers across. But Phoenix A is not a standard monster. It is what theorists now call a transitional object, a state of existence that sits between a classical black hole and a hypothetical hypermassive gravitational sink. At this unprecedented scale, the sheer weight of 100 billion suns may be too much for the local grid of the cosmos to support. The law emerging from speculative astrophysics suggests that at these extreme masses, conventional accretion disk physics begins to evaporate. We are moving beyond the violent shredding and friction that characterizes smaller giants. Instead, we are entering a realm where space-time around the event horizon exhibits macroscopic instabilities. Imagine the fabric of the universe not as a smooth sheet, but as a mesh that is being stretched past its breaking point. At the mass of Phoenix A, that mesh may finally be starting to tear. This is the multiverse leak. The theory proposes that the extreme curvature generated by Phoenix A creates localized distortions so severe that they resemble separate universes branching away from our own. You're not just looking at a hole in space, you're looking at a wound in the dimension itself. Some speculate that the photonic relay we receive from the Phoenix cluster, the light that has travelled 5.7 to 8.5 billion light-years to reach us, is carrying more than just the image of a galaxy. It may be carrying the faint, distorted echoes of other realities that are bleeding through the macroscopic instabilities of the sink. Think about what this means for our perception of scale. We used to believe that black holes were the end state of matter, the final stage where everything is crushed into a single point. But if Phoenix A has transitioned into a hypermassive sink, it might be acting as a bridge. If the singularity of a 100 billion sun mass is a rupture rather than a point, then the matter falling into Phoenix A isn't just being destroyed, it is being vented into these branching distortions. This challenges the ultimate fate of matter in the universe. We are no longer looking at a tomb, we are looking at a gateway that we are only just beginning to comprehend. This is Einstein's nightmare made real on a scale that defies even his imagination. In the gravitational cathedral, time doesn't just slow to a crawl, it begins to lose its linear meaning as it interacts with these localized distortions. If you were to hover at the lip of this leak, you might see snapshots of a universe where the Phoenix cluster never formed, or where TON 618 remained the undisputed king. The failure of Model's approach tells us that the universe is not just bigger than we think, it is far more complex than our classical physics can describe. Why does this leak occur only here? It returns to the idea of the 100 billion solar mass threshold. We proposed a theoretical size limit for black holes at around 50 billion solar masses, suggesting that anything larger would be unable to maintain its intake of matter. Phoenix A has demolished that limit. It is possible that the leak is the universe's natural safety valve, a way to manage the impossible pressure of a 100 billion sun concentration of mass. By creating these macroscopic instabilities and branching universes, the cosmos might be preventing a total structural failure of the local dark matter web. As we stare into the crimson shadow of the event horizon, we have to ask ourselves, are we seeing the end of our universe or the birth of another? Speculative narratives suggest that ultramassive black holes like this could play a role in cosmic structure formation that we don't yet understand. If Phoenix A is leaking reality, then it is not just a consumer of galaxies, it is a source of new cosmic potential. This is the edge of knowledge, where interviews, forum debates, and conflicting interpretations create a sense of active, terrifying discovery. The scale of Phoenix A forces a reconsideration of everything. TON 618 was a relic of the early universe, a direct collapse giant that told us how the first monsters were born. But Phoenix A is a messenger from the future. It tells us what happens when gravity is allowed to run unchecked for billions of years, merging titans until they become something that can no longer be contained within the 3 dimensions we call home. We are looking at a record breaker that represents a convergence point for cutting-edge astrophysics and existential dread. As we move closer to the final singularity, the light around us begins to shift into wavelengths we cannot see, as if the black hole is bleeding the colour and the very reality out of the universe itself. We have travelled billions of light years to reach this point. We have crossed the boundaries of interstellar and intergalactic space, and now we are crossing the boundary of the multiverse itself. The journey to Phoenix A is no longer a journey through space, it is a journey through the collapse of the map. We linger at the lip of the leak, watching as the light of a trillion stars is caught in the macroscopic instabilities of the sink. It is a humbling reminder that we are only just beginning to pull back the curtain on the cosmos. Somewhere out there, in the shadows of the early universe, there may be leaks even larger than this, waiting to be discovered as our observable radius expands. But for now, Phoenix A stands alone, a king, an anchor, and a wound. The throne has been reclaimed by a shadow that shouldn't exist. The sink is open, the leak is active, and as we prepare for the final chapter of our journey, we must accept that some questions will remain just that, questions. But the silence of Phoenix A is the loudest signal we have ever received. It is a reminder that the universe is not just vast and mysterious, it is a story that is still being written across an infinite number of pages, many of which are bleeding through the shadow of the largest black hole in the known universe. Chapter 10: The Unfinished Map. Our journey has taken us across the boundaries of space, time, and scale. We began this voyage on a fragile blue marble, a single grain of sand on an endless beach where every human tragedy and triumph was contained within a microscopic speck. We have travelled past the 4 million sun heart of our own galaxy and witnessed the 66 billion sun fury of TON 618. We have stood at the edge of the gravitational cathedral of Phoenix A, a titan of 100 billion suns that shatters every model of how the universe builds its giants. But as we prepare to leave the shadow of this current king, we must confront the most humbling truth of all. Phoenix A is not the final destination. It is only the furthest point we have mapped so far. We are living in a pivotal moment in human history, a time when our photonic relay is constantly receiving new signals from the deep void. For decades, TON 618 sat on the throne, undisputed and terrifying. We thought 66 billion solar masses was the absolute ceiling, a relic of a younger, more violent universe that could never be surpassed. Then, we looked deeper into the Phoenix cluster. We found a monster 50% larger, an object so massive that it challenges the very laws of physics. And yet, the lesson of Phoenix A is not that we have found the biggest black hole in existence. The lesson is that our map is unfinished. To understand why, you have to realize that we are limited by the speed of light itself. When we look out into the cosmos, we are looking back in time. We see TON 618 as it was 10 billion years ago. We see Phoenix A as it was nearly 8 billion years ago. We are seeing these monsters in their infancy or their middle age, catching glimpses of their brilliance as it was eons before our civilization ever existed. We have no way of knowing what they have become in the billions of years since that light began its journey toward our telescopes. In the time it took for the signal from the Phoenix cluster to reach Earth, that 100 billion sun shadow has likely grown even larger, devouring more galaxies and merging with more titans in the dark. The universe is about 13.8 billion years old, and the light we see now is merely a snapshot of a younger, more crowded era. But there is a deeper mystery lurking in the shadows of the early universe. Currently, our observable universe is a sphere with a radius of about 46 billion light-years. This is the limit of how far light has been able to travel to reach us since the Big Bang. But the universe is not a static room. It is expanding. Astronomers expect that as time goes on, our observable radius will expand to 60 billion light-years and beyond. Every year, new regions of space, regions that have been hidden in the dark since the beginning of time, finally reveal themselves to our senses. Imagine what is waiting in those extra 14 billion light-years of space. If we found Phoenix A by looking just 8 billion light-years away, what monsters are lurking 20, 30, or 50 billion light-years into the void? The law suggests that the area beyond the observable universe could be millions of times bigger than the part we can see. We are like ancient cartographers standing on the shore of a vast ocean, having only discovered the first few islands. We have named the kings of those islands, but the continents remain hidden beneath the horizon. This is the edge of knowledge motif that defines modern astrophysics. We are currently building the instruments that will tear down the next wall. As new telescopes come online and gravitational wave detectors become sensitive enough to hear the tectonic groans of merging hypermassive sinks, the mysteries surrounding Phoenix A will likely deepen before they resolve. We are moving toward a failure of models that will force us to rewrite our textbooks once again. We may find that 100 billion solar masses is not a record breaker, but a common occurrence in the dense, dark hearts of distant superclusters. We must accept a state of scientific humility. For a long time, we proposed a theoretical size limit for structures in the universe based on a uniform distribution of matter. We thought we knew how big a black hole could get before it broke the universe, predicting a cap of around 50 billion solar masses. But we have already observed quasar groups, superclusters, and gamma-ray burster rings that vastly exceed our predicted sizes. The problem does not lie in the universe, it lies in the limit of our imagination. The true mass benchmarks of these phenomena are likely much higher than we ever dared to expect. Phoenix A is a reminder that we are only just beginning to pull back the curtain on the cosmos. It is a bridge between the world we thought we understood and a reality that is far more heavy, far more silent, and far more creative than we imagined. The starbirth paradox and the potential for a multiverse leak through gravitational instabilities are just the first clues that the giants of the void are doing more than just destroying. They are anchoring the web, shaping the architecture of reality, and perhaps even acting as gateways to what lies beyond. As we conclude this journey, look back one last time at the scale we have crossed, from the grain of sand to the sun, from the sun to Sagittarius A star, from the heart of our galaxy to the throne of TON 618, and finally to the 100 billion sun shadow of Phoenix A. It is a progression of power that makes our existence feel infinitesimal, yet our ability to find these monsters, to weigh them, and to wonder about them is the greatest triumph of our species. The universe is vast, mysterious, and full of giants. Some are beacons of light, outshining 100 trillion suns to tell us where they are. Others are silent sinks, swallowing the history of galaxies without a sound. But all of them are part of an unfinished map. We must consider that even TON 618, despite being billions of light years away, shines with the brightness of over 140 trillion suns, making it one of the brightest objects known, yet it is dwarfed by the potential mass of the Phoenix. The scale of these black holes is both hard to visualize and hard to fully appreciate, with event horizon diameters reaching close to 400 billion kilometers. Within these horizons, our entire solar system could vanish with room to spare. To stand near such a titan would be to see the laws of physics bend before your eyes, watching as light is trapped in orbit and time stretches into eternity. An observer far away would see anyone close to the black hole frozen in place, trapped at the edge of infinity. How these giants grew so large so quickly remains one of the most haunting parts of our investigation. Whether they formed from the direct collapse of massive gas clouds or through the repeated mergers of multiple supermassive black holes, their existence pushes the boundaries of physics. Some argue that Phoenix A is the merged remnant of several supermassive giants that collided eons ago, a hierarchical masterpiece of gravity. Somewhere out there, trillions of light years into the void, a larger shadow is likely waiting. A king that makes Phoenix A look like a flickering candle. A titan that anchors a web we cannot even see yet. We are the explorers of the light, but the story of the universe is written in the dark. And in that dark there is always something larger. There is always another mystery, there is always a further horizon. The map is not complete and perhaps it never will be. But that is why we look up. That is why we follow the data. And that is why we continue the journey. Because in a universe of infinite scale, the most incredible discovery is always the one we are about to make. The throne is never permanently occupied. Until the next signal reaches us from the edge of the void, Phoenix A remains the summit of our known world. But keep your eyes on the shadows. The next giant is already calling to us across the billion-year gaps of the cosmos, waiting for us to expand our map just a little bit further. The failure of models is not a defeat for modern astrophysics. It is a profound invitation to look closer at the contradictions of our own reality. For years, we relied on a theoretical size limit for structures, believing that the uniform distribution of matter at the dawn of time created a natural cap, perhaps no larger than 2 billion light-years for galactic groupings. Yet, as we peered deeper, we discovered quasar groups, superclusters, and massive gamma-ray burster rings that shattered those predictions with ease. If we could be so fundamentally wrong about the size of the universe's architecture, we must accept that we are equally mistaken about the weight of the pillars holding it together. Phoenix A, with its estimated 100 billion solar masses, is the first definitive sign that we have underestimated the true mass benchmarks of the cosmos. We must also consider the terrifying prospect of what lies in wait as our tools of observation improve. Current estimations are based on indirect methods, measuring the frantic motion of gas or the blinding luminosity of a core. But these methods may be inherently biased toward what we expect to find. Some researchers argue that the mass of Phoenix A could be even higher than 100 billion suns, while others fear we are only seeing the objects that still have enough gas to shine. What about the silent titans? What about the hypermassive gravitational sinks that have already finished their feeding and now sit in absolute darkness, invisible to our traditional telescopes? As we transition from the age of the quasar to the era of the sink, we may find that the universe is far more crowded with 100 billion sun shadows than our current maps suggest. The history of discovery tells us that every time we think we have reached the limit, the universe reveals a deeper basement. In 1957, TON 618 was just a faint blue star in a survey. Today, it is an ultra-massive colossus that defines a generation of research. Phoenix A has now taken that crown, but it too is a relic of light that travelled for billions of years to reach us. We are looking at a snapshot of a king from the distant past. As our observable radius continues to expand toward the expected 60 billion light-year mark, we will inevitably uncover structures that make the Phoenix cluster look like a local neighbourhood. The area beyond our current vision is estimated to be millions of times larger than everything we have ever mapped. Ultimately, objects like Phoenix A force us to ask the most existential question of all. What is the ultimate fate of matter in a universe of infinite growth? If hierarchical merging is the rule rather than the exception, then the giants we see today are merely the seeds for the titans of the future. We are witnessing a cosmic construction project that will span trillions of years, long after the last star in our galaxy has flickered out. The king has not just reclaimed the throne, he is the foundation of the palace itself. As we look back across the billions of light years that separate our small world from the shadow of the Phoenix, we are left with a single haunting certainty. The map is unfinished, the giants are still growing, and the most terrifying discoveries are still waiting in the dark. The journey into the unknown is only just beginning.